So the problem says to simplify, and this is a problem given in scientific notation. So before I do the problem, let's just do a little review of scientific notation. Scientific notation is usually used for writing very large numbers or very small numbers. The general form for scientific notation is a times 10 raised to the x power, where this number a always has to be a number that's greater than or equal to 1, but less than 10. And then this exponent up here has to be an integer, so a positive or a negative whole number. So some numbers, or some examples of numbers that are written in scientific notation, would be 5 and 25 hundredths times 10 to the 8th power. So what that really means is you're taking 5 and 25 hundredths and you're multiplying it by 10 8 times. And then you would do that 8 times. Or if you had a negative exponent, if you had, let's say, 2 times, or 2 and 4 tenths times 10 to the negative 3rd power, what that means is you're taking the number 2 and 4 tenths, and this negative 3 actually means that you're taking 2 and 4 tenths and you're dividing it by 10 3 times. So you'd actually be dividing by 10 once, dividing by 10 again, and dividing by 10 again. Now the shortcut for doing either of these problems is, remember, when you're multiplying by 10 or you're dividing by 10, you just have to move the decimal point. So in this first example, the 5 and 25 hundredths times 10 to the 8th power, all I would really need to do is take my decimal and move it 8 places to the right, because I'm multiplying by 10 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. And then you would fill all of these with zeros. Where the second example, 2.4 times 10 to the negative 3, when you're really dividing by 10, it would mean you would take your decimal point and you would actually divide by 10 3 times. So you would actually move your decimal point to the left 3 times. So if we moved on and we looked at some examples of numbers that are not written in scientific notation. So for example, if I wrote the number 15 and 2 tenths times 10 to the 4th. That is not written in scientific notation because this number has to be less than 10. So what I would actually have to do is I would need to move my decimal point over here and make it 1.52. That now is less than 10 but greater than or equal to 1. And I would multiply that by 10, but instead of raising it to the 4th power, where here, when the decimal point was right here, I had to multiply by 10 1, 2, 3, 4 times. Since I moved the decimal point here, now I would have to multiply by 10 5 times. So this exponent then would become a 5. So again, this number, and I'll write it again, the 15.2 times 10 to the 4th, that actually is not written in scientific notation. You would have to change it to this. So you have to make sure that this number is greater than or equal to 10. I'm sorry, greater than or equal to 1, but less than 10. So now that we have a little bit of review of what scientific notation is, now we'll go back and look at the problem. So now let's look at our problem. It is 1 and 2 tenths times 10 to the negative 6 divided by 4 and 8 tenths times 10 to the 4th. So since I'm dividing two numbers that are written in scientific notation, the first thing I can do is I can just divide the 1 and 2 tenths and divide that by 4 and 8 tenths. And then separately what I'm going to do is I'm going to take the 10 to the negative 6 and I'm going to divide that by 10 to the 4th. So I can kind of break that up, and I'll still keep that multiplying in there. Divide that into kind of two separate problems. So first, when I take 1 and 2 tenths and I divide that by 4 and 8 tenths, I get 0.25. And then 10 to the negative 6 divided by 10 to the 4th. When you're dividing numbers that are written as a power and they have the same base, all you have to do is subtract the exponents. So I'll just do this over here. This 10 to the negative 6 divided by 10 to the 4th, That's the same thing as 10 to the negative 6 minus 4. So again, because you're dividing, you subtract the exponents. You take the exponent in the numerator and you subtract the exponent in the denominator. So that would give me 10 to the negative 10. So this becomes 0.25 times 10 to the negative 10 power. So at first glance, you might think that this is your answer. But then when you look at the choices, that isn't over there. And the reason is because this number right here, this number is not greater than or equal to 1. Remember, in scientific notation, this number has to be greater than or equal to 1, or it has to be less than 10. It is less than 10, but it's not greater than 1. So I would actually have to move my decimal point. So in order to get a number that's greater than or equal to 1, I would need to move my decimal point. I would have to move it so that it's right here to make the number be 2.5. Then I'm going to multiply that by 10, but I have to look at this exponent, negative 10. Now, when the decimal point was right here, and when it was times 10 to the negative 10, it meant what I would do is I would actually divide by 10 times. So it means I would take this and I would divide by 10 times, which would move the decimal point to the left 10 places. But because I moved my decimal point here, I'm not going to divide by 10 times. I actually have to divide by 10 one more time, right? Because to get my decimal point to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I want to get that decimal point in the same spot, but since I've moved it once, one unit or one place to the right, I actually have to divide by 10 now 11 times. So this is going to become a negative 11. So if I look up here, 2.5 times 10 to the negative 11 now is letter D. So I think one thing that's tricky is you have to make sure that that first number is less than 10 but greater than or equal to 1. And then you have to look and see how would I have to change my exponent. Now the other thing you can do is if this is a calculator problem on the MCA test, you can always just plug this into your calculator. I mean, if you know how to do exponents, you can always just take 1.2 times 10 to the negative 6, put that in your calculator, divide it by 4.8 times 10 to the 4th. And the calculator should put it into scientific notation and make sure that that first number is greater than or equal to 1 but less than 10. So our answer here for this problem is D.